Alright, ladies and gentlemen, this is Mark Anderson for Keller Community College for our 5th video of 6 to talk about a Unit 4 test review for statistics, and we're going to do a goodness of fit test. There were two types of goodness of fit tests when we're dealing with chi-square distribution. There's a preference check to see if there was a preference between something versus like one of several options, and there was also going to be a test to see whether percentages fit reality. So in this first of two examples, this one here is a preference test because it says, according to a survey of 100 people, the following results are what they did to combat daytime drowsiness. With an alpha of 10%, or in this case, a confidence interval of 90%, can we be certain that there is a preference for a specific method? So the null and alternative hypothesis is basically going to be, the null is going to say that there is no preference. This is the guy who's saying that there's nothing going on. There is no preference, and the alternative is there is a preference. So what we need is an observed data and an expected data. Now here's what we observed. I'll just abbreviate that as OB. We observed that 35 out of this 100 people took a caffeinated beverage, 27 took a nap, 17 took a walk, a snack, or some other method. Now what we're expecting, if there is no preference, is that these 100 people would be evenly broken up into these 5 groups. So this is technically 20, 20, 20, 20, and 20. Now we notice that there's quite a bit of difference between some of these groups and not others. So our process, after we do this null and alternative hypothesis, our process is to find out what the critical value is. So for step 2, so if this is step 1, step 2 is we're going to find that critical value. So our alpha is going to be at 10%. This is going to be a right-tailed test, since we're going to see if this data is inside of that critical region. We're going to look at table G in our book here, which is the chi-squared table, and we're going to look up our alpha at 10%, and our degrees of freedom isn't 100 minus 1, it's 5 categories minus 1, so 5 minus 1, which is 4. So at 4 degrees of freedom, looking at a right tail at table G, our chi-squared right critical value is going to be 7.779. So if we're further to the right than 7.779, then we are going to be in the critical region, and we can reject the null hypothesis that there is a preference. So what we do for step 3 is we look at the differences between these two and square them. Now I'm going to subtract observed minus expected, so most of these are going to turn out positive. So this is going to be 15 quantity squared divided by how many we expected in that group, because it's observed minus expected squared divided by expected, plus 27 minus 20 is 7 squared divided by 20. And then we have negative 3 squared divided by 20. So all these numbers will turn eventually positive. So if you took the absolute value and then squared them, you would get the same answer. But I'm just following the formula that's in the book, which is observed minus expected squared divided by expected. Plus, in this last situation, 12 squared divided by 20. So if I compute all of that, I get an answer of 23.8, which is for step 4, when I look at my skewed right curve of our chi-square distribution with 0 on the right, our critical value here was set up at 7.779, and we blew way past that with 23.8. So our step 5 is going to be to reject the null hypothesis, because 7.779 is much less than 23.8. And yeah, there's a preference. I know that some of these are pretty close, but I mean, if you look at the difference between other and beverage, I mean, there's just so much difference than what we expected. There's definitely a preference. Looks like people are going for those energy drinks there. All right, well, thank you for watching, and on to our last video. Thank you.